Hi students, welcome back. We are going to talk about flex sensor in this video. So what exactly is flex sensor? We have flexible body parts which are supported by muscles, and this sensor is actually mimicking the action of our human muscles. So for example, you can take the example of our fingers. We flex them and we can generate different powers to pull or push something. So similar way, this sensor is also of the size of human finger, around 2 to 3 inch, and we can bend it to generate different values. So what are those different values? These are basically resistor values. So this sensor is a variable resistor, and the resistance will change if I change the amount of bend on this sensor. So this is like a strip which is around 8 centimeters, and it can be available in different sizes also. This is the most standard one that is available in the market. So how does this work? As we said, it is like a straight strip. If it is in the regular position, the resistance is a nominal value. If I start bending this, the resistance will start increasing. As I keep on bending it, the resistance will keep on increasing. You should not bend it too much because it can break. So it is only a resistor, it cannot work alone. We have to use it in series with another fixed or variable resistance to make a voltage divider and take the output from this voltage divider circuit. I have a question for you. Can you recall any other sensor which was used in the very similar way? Right, LDR. LDR was used in a very similar way because LDR was also acting like as a variable resistor. So LDR or flex sensor, both of them have almost same working principle. Their way of detection is different. LDR is detecting light, whereas flex sensor is generating different resistance on bending. So how do we use them in the circuits? Let us check it on Tinkercad now. So in the Tinkercad library, if you scroll, you may not find the flex sensor right away. So we can search it. So here is the sensor that we have. And now we are going to test what is the range of resistance that this sensor is offering. So we are going to take a multimeter in the resistance mode, and we are going to connect these terminals to the multimeter terminals. And for resistance, you don't have to worry about positive, negative. Okay, so the connections are made. I have just made different color of wires, and I am going to start my simulation now. So in the straight position, it is 30 kilo ohm, and now you can just hold it and you can bring the cursor down. So you can see it is bending by degrees, 30 degree, now 90 degree, and you can rotate up to a maximum of 180 degree. So at 180 degree, it is 163 kilo ohm. At around 90 degree, it is 70 kilo ohm, and at straight position it was 30. So we are going from 30 to 160 in an almost linear way. So now we know that what is the range of resistance that we get. Now if you remember, if I have to put something in series with this, that should be around the center value, right? So around center value was around 70 kilo ohm, 70 75, right? So you can take 100 kilo ohm also. That is all up to you. How do you decide? So we are going to stop the simulations, and we don't need the multimeter now. We are going to drag a resistor. We need an Arduino. Then we are going to take one LED and one more resistor for the LED. So this resistor, which is going to be in series with my flex sensor, I am keeping it 100 kilo ohm. This resistance, which is for the LED, I am keeping it 330 ohm. So I am connecting this at pin number 13 and the LED cathode goes to ground with a black color wire. Now this resistor is in series. You can drag this little downside. So here I am going to connect, let me connect on this side, that will be better. Terminal 1 or terminal 2, anyone can go to ground and VCC. So this is going to VCC and this terminal will go to ground with a black color wire. Now this is our junction. We are going to take it to any of the analog pins. So you can take it at A2, anyone, right? Now this one we can keep a different color. So the connections are done. Let us come to the coding part. Our part is very simple. We are just going to detect the flexibility of this flex sensor, and if the rotation is more than a certain degree of angle, then the LED will glow. And now you can imagine that you can do a lot of things with this sensor. You can also align it with a linear change in the angle of rotation of a servo motor as well. So let us go to the coding part. We are saying we have a simple if else statement. We don't need these LED blink, we can remove it. Then we say okay, we are going to compare. So we bring it. What do we compare? We are going to read the analog pin. So we keep this analog pin at the first position. Okay, now we have to do some mathematics. This is 100 kilo ohm. This one is 30 kilo ohm right now. I am connecting 5 volts towards 100 kilo ohm and 30 kilo ohm is towards the ground. That means the central value in terms of voltage is on the lower side, because lower resistance is towards the ground, higher resistance is towards the VCC, and I am measuring the voltage between the junction and ground. So lower resistance is going to give me the lower voltage. As I am going to bend this sensor, this will give you higher and higher value. Okay, and then you will see more output coming. So I can keep it somewhere in the center, or maybe for, yes, 500 is fine. Then we say okay, if analog read is greater than 500, then set the built-in LED or pin number 13, both are same because we are working on pin number 13. Put a delay, never forget to put a delay. So it is high when the bend is very high and otherwise it is low. So simple program, you can see the text part also. A0 is input pin, 13 is output pin. If analog read A0, now you have to cross check. You have connected at A2. So in the coding part, you should make it A2. So if A2 value is more than 500, 13 will be high, otherwise 13 will be low, and every time there is a delay of 1 second. So let us start the simulation. So right now we were expecting that the angle is on the lower side, so resistance is on the lower side, LED is not glowing, so that is happening. Now I am going to bend the sensor, and as I increase the bend, now you can see the LED is on. If you want to precisely note down that at what angle we achieved the value of 500 analog, you can use serial monitor to keep on printing the input data of A2. So Now you can see that if I have small devices and small concepts, you can keep on integrating them to make slightly larger and interesting applications. So we have discussed a variety of sensors. We are going to discuss a very interesting input device, and that is a keypad. You would have seen these keypads on your telephone or calculators. So how do we use that with Arduino? We are going to discuss in our next video. Thank you.